10th graders, welcome to class 85. Let's do this. Today is a lecture, okay? And specifically, we are learning about specific heat versus latent heat. Okay, so I'm going to start with a couple quick formulas. We're going to manipulate one formula that you already know, and then we're going to look at one new formula, and then we're going to talk about how these operate in the real world. Okay, so this first formula you've seen before. We have the specific heat of a substance is equal to the amount of heat energy divided by the mass of that substance times the change in temperature. Okay, now I'm going to change this formula. I'm going to manipulate it. So we're going to put this specific heat capacity over 1. And then this time we're gonna isolate the Q, okay? The heat energy. So let's cross multiply. Q times 1 is Q. And then if you do specific heat capacity times mass times delta T, then you get them all on the right side. I'm gonna put mass first because that's the way that you see it written typically. So it's gonna be mass times C, variable for specific heat capacity.
According to Wikipedia, for example, at a temperature of 25 degrees Celsius, the heat required to raise the temperature of 1 kilogram of water by 1 K is 4.
Yeah, I just want to make sure it's uppercase. M capital C, and then delta T, right? When you multiply the C times the M delta T, that's what you get. Okay, now let me give you a tiny introduction to this formula, and then we're going to look at the other formula. What is this for? Well, as a review, this is describing, wow, my video right here is really slow. This is describing the amount of heat energy required to change the temperature of a certain mass of a substance according to its specific heat capacity by a certain amount of degrees Celsius or Kelvin. Okay, so it's talking about the amount of energy required. Okay, and this is specifically when the phase of that substance does not change. Okay, this is when, for example, a solid substance remains solid, or a liquid remains liquid, or a gas remains a vapor. Now, let's look at one other formula really fast. This formula is written as follows: Q, still referring to heat energy, is equal to the mass of the substance times L. Okay? L is what we call latent heat. Okay? And every substance has a latent heat. Now, there's 2 types of latent heat. Okay? This will make more sense after we go through this example, but let me tell you the 2 types really fast. The first type of latent heat is what we call the latent heat of fusion. Okay? The second type is what we call the latent heat of vaporization. Okay? Now, what is the latent heat of fusion? The latent heat of fusion is describing the energy required to change the phase of a liquid to a solid, or a solid to a liquid. Latent heat of fusion. Solid to liquid, or liquid to solid. Okay? The second type of latent heat we're going to talk about is the latent heat of vaporization. Now, as you might guess, the latent heat of vaporization is describing the energy required to change the phase of a substance from a liquid to a gas, or a gas to a liquid, hence vaporization. Okay. Now, both of these are super important, and they're going to be very useful for us in this example today. Your homework, I'll describe at the end of this video. Okay, cool. If you want to fast forward to the end and listen to it, no problem. Then you can come back here. Whatever you prefer. So let me move this. Okay, actually, you know what? We're gonna leave the title here. I think it's better like that. Okay, so here's our example for today. Today's just theory, basically just theory. Class 86 is coming after this, because we're not gonna have a class 85 solutions video, because your homework, you'll see in the end, is a selfie video that you sent to me with some very specific expectations. There's bugs flying around in my house right now. Okay, so here's the example. We're going to use the example of a block of ice, okay? And it doesn't matter what mass this block of ice is right now because we're not actually performing the calculations, we're just gonna describe them. But we're gonna have a block of ice, and we're gonna say that this block of ice starts at negative 40 degrees Celsius. Now remember, the temperature at which solid turns to liquid and liquid turns to solid with water is 0 degrees Celsius. That's the freezing point or melting point of water. Okay, so this block of ice we're starting with is at negative 40, so like way colder than the freezing point. So it's like rock hard. If you hit it, it would sound like glass probably, or like clinking metal, right? When it's super cold, that's what ice sounds like when you like hit it with like a bar. Okay, so we're gonna start with this block of ice, and then what we want to do is we want to heat it up to the point where it becomes liquid, and then gas, and then not only gas, but we want to heat it up to 160 degrees, 160 degrees Celsius in the form of vapor. Now remember, the boiling point of water is 100 degrees Celsius. So after we heat up this ice and it would turn to liquid, and we heat up the liquid and turn it to gas, from that point, when it turns to gas, is at 100 degrees Celsius, the boiling point of water. What is boiling in Spanish? You know. From there, we're going to heat it up 60 degrees more to 160 degrees Celsius. So super hot vapor. Okay. So let's talk about the calculations required to make that happen. Okay. There are five specific steps in this process. Okay. So let's go. First of all, we need to heat up this ice all the way from negative 40 degrees Celsius all the way up to 0 degrees Celsius. All solid, all still ice, okay? Now, to calculate the energy required to heat up that ice to 0 degrees Celsius, which formula would we use? We'd use this one. We have a mass, whatever the mass is. We know the specific heat or specific heat capacity of ice, I'll tell you right now, is different than the specific heat capacity of water. We talked about the specific heat capacity, this variable, the C, for liquid water, we talked about before, is 4,186 joules per kilogram times degree Celsius. Joules per kilogram times degree Celsius, yeah. But the specific heat for ice, you don't need to remember this number right now, but the number is 2,090. I think I killed him. 2090, 2090, because the specific heat capacity of ice is different than that of liquid water. And it's also different for steam, you'll find out. Okay, so using this formula, we can calculate the energy required to change the temperature of that ice. Okay, but once using these, this calculation, we don't melt the water yet. We don't melt the ice. It's still solid. And then once it's solid, there's another process that happens in order to actually change the phase of the ice from solid into liquid. What do we call that? It's called the latent heat of fusion. Latent heat of fusion. Okay. Now to calculate how much energy is required to change that 0 degree temperature ice cube into, or block, into a 0 degree pool of water, we use this formula: the mass times the latent heat of fusion, in this case of water. The latent heat of fusion of water, you don't need to remember this, but the latent heat of fusion, that is the energy required to change a certain mass of water from solid to liquid, is 333,000. That would be joules per kilogram. So joules divided by kilogram. Again, you don't need to remember that number. Okay. So right now we're in the second step. The first step was heating up the ice to 0 degrees Celsius. The second step is changing the phase of the ice from solid to liquid. Okay. We would use this formula to calculate the energy required, because now we now know, like I told you, the latent heat of fusion of water. From there, we go into step 3. Step 3 is heating up the water from 0 degrees, now it's all liquid, from 0 degrees Celsius all the way to the boiling point, which is 100 degrees Celsius, right? And this is all still liquid. This third phase, we're going to use the mass, whatever the mass of this original ice block was, the specific heat or specific heat capacity of water we know from last class is 4,186 joules per kilogram times degree Celsius. And then the change in temperature, in this case, it would be right here in step 1, heating up the ice. The change in temperature was 40 because we went from negative 40 to 0. Now, step two we just said was the phase change from solid to liquid. Now, step 3 is heating up the water, and this temperature change in step 3 is going from 0 degrees Celsius all the way to 100 degrees Celsius, right? All still liquid. So we'd use this formula. And then we have that much water, right? All liquid still at exactly 100 degrees Celsius. It's at this point that it can start to boil. That is, turn to steam, turn to vaporize. Okay. Now we enter the fourth step of this process. That is the latent heat of vaporization. Okay. The latent heat of vaporization is different than the latent heat of fusion. Once again, latent heat of fusion is solid to liquid or liquid to solid. Latent heat of vaporization is liquid to gas or gas to liquid. Okay. So the latent heat of vaporization of water, you don't need to remember this number, but it's a really big number. 2,260,000 joules per kilogram is the latent heat of vaporization of water. So we would use that formula based on whatever mass this original ice block was, times the 2,260,000 joules per kilogram to figure out how much energy is required to completely vaporize this water, turn it from the liquid to the gas at 100 degrees Celsius. From there, we enter the last and fifth step, which is heating up that steam, right? We just converted it according to this formula, according to these calculations. We just converted that 100-degree liquid water into 100-degree steam, right? Temperature didn't change, but energy was required to change the phase, right? Okay, so now we have 100 degrees. We have steam that's at 100 degrees. We need to raise the temperature of that steam to 160 degrees Celsius. So now we're going to go back to this formula. At the end of this video, I'll give a small summary of each of these steps. So now we're in the fifth step of this process, changing the block of ice to really hot steam. So the change in temperature now in this fifth step is going from 100 to 160. So the change in temperature is 60 degrees Celsius. Or you could say Kelvin, because the change is the same, like we talked about. The specific heat capacity of steam is not the 2090. It's not the 4,186. It's a different number for H2O that is steam. And the specific heat capacity of steam, of H2O, is about 2010. If you look up the specific heat capacities, I tell you, there's some small variations as far as what people consider to be the most precise specific heat, but it's more or less 2010. 2010 is a specific heat of water when it's vapor, okay? So we're talking about how much energy is required to change a certain mass of vapor by a certain amount of degrees, okay? So change in temperature is going to be 60 from 100 to 160. Specific heat capacity of steam, like I said, 2010 about, and then the mass, whatever mass we had, right now we're not paying attention to the amount of kilograms, right? And that would give us the amount of energy required to change that quantity of steam by 60 degrees Celsius, okay? So there's our 5 steps of this process. I'm really curious how long this has taken so far. 14 minutes. Okay, so let's review these 5 steps really fast. First step is from really cold ice to ice still solid at 0 degrees Celsius, okay, according to this formula. Second step is melting the ice, right, according to this formula, right, based on the latent heat of fusion, okay, of water. That's the phase change in step 2. Step 3, now that we have all liquid, all the ice melted. We want to heat up this liquid, and this third step is all liquid, right? Heat up this liquid from 0 degrees Celsius to 100 degrees Celsius, right? According to this formula, the delta T is 100. The specific heat capacity of water we already know is 4,186, and then whatever mass we have, we would put there in kilograms, right? There's the third step, heating up the water, all liquid. Fourth step is the phase change, the latent heat of vaporization, changing the liquid water into steam. That's the fourth step. According to this formula, here's the mass, and here's the latent heat of vaporization, which is, in this case, 2010 joules. Let's see, 2000. I think that before I told you that the latent heat, I told you the number for the specific heat of steam when I was trying to tell you the latent heat of steam. Let me clarify this really fast. The latent heat of vaporization of water, the amount of energy per kilogram required to change the phase of water from liquid to vapor is actually 2,260,000. And then the specific heat of steam, the fifth step, changing the temperature of steam, is 2010. Don't worry about those numbers right now, because right now we're learning about the theory. Those numbers will be clarified if you ever have to do calculations, so don't worry about that. But back to the summary. Fourth step is, like I said, changing the phase of the liquid at 100 degrees into steam, okay? According to this formula, okay? This is latent heat of vaporization. And then the fifth step is changing that steam, changing the temperature of that steam by 60 more degrees. So then we're at our final goal of steam that is at 160 degrees Celsius, okay? So there's the 5 steps you'll have to, that will be part of your homework. In a minute, I'll tell you your homework. But let me tell you these numbers really fast. Now, don't worry about the actual numbers of specific heat capacities and latent heat of fusion and vaporization, because we'll talk more about that if you need to know it. But the important thing is that you understand those 5 steps and which formula you use for each step. There is the lecture for specific heat versus latent heat. Now you understand a little bit more specifically kind of what energy is required and in what way for a block of ice to transition into really hot steam from negative 40 degrees Celsius to positive 160 degrees Celsius. Okay, so now let me describe your homework assignment. Let me just say from the get-go right now, if you disobey one of these instructions, you'll get a 0. Okay, because I don't have time for students that don't follow instructions. Okay, so listen carefully to these instructions. First part of the instructions is your homework is a selfie video. Okay. Number 2, your video cannot be you reading or you saying something memorized. Okay, it needs to be you speaking intelligently. Okay. Third piece of the instructions is your homework is to describe those 5 steps that I just talked about. Okay. The 5 steps required for the negative 40 degree block of ice to transition into the positive 160 degrees of steam, the steam at 160 degrees Celsius. Okay. So your homework is to describe those 5 steps. You need to mention every step that I mentioned in your video if you want the point, okay, for this class 85 assignment. I'll be listening very carefully for every step. If you say 4 steps and not 5, then it'll be a 0, okay? I said it. Next part of the instructions is, I don't remember if I said this, but I'll say it again just in case. Your video needs to be 30 seconds or less, okay? 30 seconds is good. 29 seconds is good. 15 seconds is good if you can get all 5 steps in there. But if you send me a video that is 31 seconds, it's a 0, okay? So 30 seconds or less to say all those 5 steps and describe them briefly. And your descriptions don't have to be super long. If you just mention the step and say briefly, just tell me what it is, that's good enough for each of the 5 steps. Next, your video must be sent to my WhatsApp. I'll give you my WhatsApp number in Google Classroom again. It needs to be sent to my WhatsApp by 6 p.m. Okay? That means at 6 p.m. or before. Now, if you send it at 6:01, it's a 0. Okay? I know it sounds strict, but I have to draw the line somewhere, or else it's really chaotic. Okay? So if you send it at 6:01 tonight, it's a 0. Except if you had internet problems. But if you have internet problems and cannot send me the video, you need to do this. Take a screenshot in WhatsApp of you trying to send me the video. Okay. If you have no internet or no power, take a screenshot of your screen in WhatsApp, trying to send me the video. And in your screenshot, it needs to show the video already recorded, trying to send in WhatsApp, and it needs to show the time before 6 p.m. Okay, in that screenshot. Then once you have internet, then you will send me the video, and you'll send me that screenshot that proves that you had the video ready and that it was ready before 6 p.m. Okay. Yeah, that's everything. That was your guys' lecture on specific heat versus latent heat. Once again, don't worry about the numbers. Those are the minor detail. The numbers as far as specific heat and latent heat, those are numbers that will be more relevant later. But just make sure you understand those 5 steps required. So yeah, that's everything. Have a great day, and we'll see you guys next class.